Hello, and welcome to a new lecture. Containers have revolutionized how applications are developed and deployed, offering flexibility, scalability, and resource efficiency. However, with the widespread adoption of containers, there are several security challenges that organizations must address to ensure the integrity of their containerized environments. Containers, due to their lightweight nature and the shared use of the host operating system, come with unique risks that differ from those of traditional virtual machines, VMs, or physical environments. One of the primary security challenges in containerized environments is the inflow of vulnerable source code. Containers are often built using open-source software, and developers regularly update and store container images as needed. This continuous integration of third-party code can result in vulnerabilities or unexpected behaviors being introduced into an organization's infrastructure. Since containers are typically used to automate deployment processes, it is crucial to ensure that the images used are properly vetted for security flaws before they are deployed. Another significant risk is the large attack surface inherent in containerized environments. As organizations deploy hundreds or even thousands of containers across multiple machines, the complexity of tracking and managing the security of all containers increases. Each container is a potential entry point for an attacker, and monitoring activity across such a large number of instances can be challenging. This is further complicated by the lack of visibility introduced by the abstraction layer created by container engines, which can make it difficult to detect malicious activity or anomalies within individual containers. The speed of DevOps processes also presents unique challenges in container security. Containers are highly ephemeral, with an average lifespan significantly shorter than that of VMs. Containers can be created, run, and deleted within seconds, and this speed makes it possible for attackers to execute attacks and disappear before detection mechanisms can respond. Given the short life cycle of containers, traditional security approaches are often insufficient, and organizations must adopt automated security solutions that can keep up with the dynamic nature of container environments. The behavior of containers running on the same host can also lead to risks, particularly in the form of noisy neighbors. Containers share resources such as CPU and memory, and if one container exhibits excessive resource usage, it can affect the performance and stability of other containers running on the same host. For instance, a container opening too many network sockets could cause the host system to freeze, impacting all other containers. This type of behavior, if not properly managed, can lead to a denial of service, DOS, for other containers. One of the most serious risks associated with containers is the potential for container breakout, where a compromised container gains access to the host operating system. Since containers share the host OS, any security vulnerabilities in the container configuration could allow an attacker to escape the container and interact directly with the underlying OS. Once the host OS is compromised, the attacker could gain access to other containers running on the same machine, leading to a system-wide security breach. Network-based attacks are another significant concern in containerized environments. Containers often interact with external networks, and if a container is compromised, it becomes vulnerable to external threats, such as raw socket attacks. Additionally, inadequate network security configurations can allow a compromised container to communicate with other containers or systems within the same network, potentially spreading the attack. To mitigate these risks, organizations must adopt comprehensive container security best practices. One of the most important measures is to limit the communication between containers to predefined segments. By utilizing network firewall technology and configuring proper segmentation, organizations can prevent unauthorized connections between containers, thereby reducing the risk of lateral movement by attackers. Another best practice is to implement container image signing and verification. Since container images can harbor vulnerabilities, it is essential to ensure that only trusted images are deployed. This can be achieved by requiring image signing, where each image is cryptographically signed by the developer or organization that created it. Before deployment, the signature can be verified to ensure the image has not been tampered with. Image scanning services, which analyze container images for known vulnerabilities, should also be integrated into the deployment pipeline. Organizations should also implement fine-grained access control to limit who can create, modify, or deploy containers. Containers should not be run with root privileges, as this can increase the risk of a breakout. Instead, role-based access control, RBAC, should be enforced to ensure that users only have the permissions necessary for their specific tasks. By minimizing the number of privileged users, the organization can significantly reduce the potential attack surface. Container runtime security is equally important. Containers should only run the processes necessary for their intended function, and access to file systems, network resources, and external systems should be restricted. Mount points should be configured as read-only whenever possible to prevent unauthorized modification of files. Additionally, runtime security monitoring should be implemented to detect suspicious activity within containers, such as unexpected process executions or abnormal network traffic. It is also essential to address the risks associated with secrets management within containers. Containers often require sensitive information such as passwords, API keys, or access tokens to interact with other services. Best practices dictate that secrets should never be hard-coded into the container image. Instead, secrets should be injected at runtime using secure vaults or secret management tools. Secrets should also be encrypted, and all operations involving secrets should be logged for auditing purposes. Lastly, organizations must regularly audit their container environments to ensure compliance with security policies. Auditing includes reviewing container configurations, monitoring network activity, and verifying that images are up to date with the latest security patches. Automated tools can be used to scan containers for vulnerabilities and misconfigurations continuously, reducing the likelihood of a breach. So, while containers offer many benefits in terms of agility, scalability, and resource efficiency, they also introduce new security risks that must be carefully managed. By implementing best practices, such as limiting container communications, enforcing image signing and verification, applying fine-grained access control, and securing secrets management, organizations can significantly reduce the risks associated with containerized environments. I hope that was clear for you. See you next.